All right. Then, yeah, it's great to have so many of you to this talk, Live Programming and Designing of Dynamic Web Applications. This is a talk that is about tooling, I would say, and we will see what that means in a minute, and you will probably see a lot of stuff that you have not seen before, I would assume, or maybe we can check who of you has experience with Smalltalk. That's actually a lot, okay. Nice. Then, like around 50% of you have seen a lot of this. But yeah, we will see how we use some ideas of these live programming systems, such as Smalltalk, inside of lively.next to utilize them for web development. And yeah, my name is Linus, and I also show you my colleague Robin, who unfortunately cannot be with us today, but we will talk about him later, and now you're warned, he will appear again. We are both full-time developers of lively.next at the moment, and yeah, if you want to, I don't know, check out what we do, have some questions, have thoughts after this talk, want to rant, then you can find me here. Looking forward to hearing from you, and also slides and all code for the demo and stuff will be there, and also on the FrOSCon page, so you can check that out if you'd like. Yeah, so what do we want to do today? First, I will introduce some programming ideas, I would say, and these are not in the sense of, we're not going to talk about specific syntax elements or stuff, but more broad ideas on how we interact with computers and what works about that and what maybe does not work so well. So let's say we will talk about computing ideas, and these ideas will lead us to Lively, its history, and ultimately to lively.next. And we will see a bit about what it is, what it does, and also dive for a moment in how it actually does this. And ultimately, we will take all of this together and yeah, see how we use Lively as a rapid application development IDE for web apps. Okay, you've been warned, we will talk about tooling. And if we talk about tooling on a general level, the question one should ask, in my opinion, is how and why do we interact with computers? And now I assume most of you here are programmers. So for us, the question then becomes, how do we write software? And on a general level, this always looks kind of the same. So you sit there and you write some code. Maybe you have a specification from a customer, or you're hacking only for yourself, or you have a driver ticket, whatever. But in the end, you will sit there and write code, and then you hit a button and you need to wait. And depending on what you're doing, you need to wait quite a bit, because, I don't know, you're working with some large compiler tool chain. But even if you're in web development, you will probably have something like rollup or other bundlers inside of your tool chain, and there is a meaningful delay there that you can probably feel, even if you have these modern tools with hot reload. We talk about like a few seconds delay here, and then you will go inside of your browser if you do web development and take a look at what you've just coded up. And then there are two cases. Either you have succeeded in what you wanted to achieve, that's nice, then you can go on to the next thing, or it did not work out as you intended, but you needed to wait this time to check that, and then you have this kind of iterative process there. And I think there are a few problems with this. The first is that waiting is not fun. So we would like to eliminate the waiting part as much as possible. And the second problem we have with this waiting time is that we think it makes coding much harder, because you need it makes coding more abstract in the sense that you need to hold more information, more context on what you're doing inside of your head, because you have no instantaneous confirmation of the mapping from your idea to the code to what is actually on the page later. You need to hold that inside of your head. And that not only distance us kind of from our work, but it also increases the cognitive load a lot. So yeah, we think we need to reduce this this waiting time, and that's a lot of what we will talk about today. And this is not a new idea by any means. This is the dissertation of Ivan Sutherland. It's called Sketchpad. It's from 1963, so back then a computer was something very different than it is today. And we will see a video of it working in a minute. But he had already the idea that it would be nice if we could directly interact with our programs and manipulate them in a more direct way without any kind of cognitive mapping from thing that I actually want to work on to some variable name to some abstracts to back, and I need to hold all of this information in my head. But it would be nice if I could just grab what I wanted to work on and do what I need to achieve. So this thing is a kind of CAD application, I would say, CAD. And what you will see is that you can very directly give commands via this button row here, and then you also have a light pen with which you can issue other commands and end commands. And in the end, this is like, it may not look like this, but you will see in a minute, in a second, it will begin moving. Yeah. So what it does here, it makes everything perpendicular. So this is a fully fledged constraint solver, very impressive for this time, and a mode of computing that allows you to very directly get a feel for what you're doing. There were a lot of other impressive ideas in this already. For example, you have like objects and kind of prototype ideas in there. But the point we want to drive home here is you directly manipulate what you're working in, and you get immediate feedback. Yeah, now we can see exactly how the thing he just created does not now appear again as an object, and he can merge that with something else he worked on. And I'm not sure if that's in the video, but we might see him doing that again with new. Yeah, exactly. So you can also copy that and stuff, and then change them independently of each other. And he already had that concept of like a hierarchy of prototypes. So if one would, for example, go to the original screw he made there and change something there, then all other screws would be impacted. But the derivations you can change independently of the higher order. Whoop. Okay, so now we have seen, okay, it's kind of cool if we can directly work with this software in general. And the next thing on our ladder of ideas here would then be Smalltalk. And Smalltalk has invented a lot of stuff. It comes from Xerox PARC. At Xerox PARC, they invented even more, a lot of crazy stuff. So we have object-oriented programming that originates from Smalltalk, but we have it only in brackets here, so I think that's telling a lot already. They also went ahead and just invented GUIs, the drop-down menu. Ethernet was developed at Xerox PARC, so yeah, in general, I can highly recommend. There are a lot of really great books about what happened at Xerox PARC, what Alan Kay, Dan Ignals, and others did there. Highly recommended to check that out. But what we want to focus on here is this idea that the whole Smalltalk system in itself is live, so you can manipulate the system while you work with it. And that is true for every single part of the system. So with Smalltalk, it's running in its own VM. It can do that a lot further than what we will see in a minute, because what we will see with Lively is that we are inside of the JavaScript VM, of course, because we are running in the browser, and that does not allow us to do anything we want, but already a lot. With Smalltalk, they could go completely crazy, and basically you could change every part of the system and even the language itself. So Smalltalk is written in Smalltalk. So if you'd like, you could go ahead and change the meaning of the if-else statement while running this thing. And you can, and we will see in a second a practical example of this, but you can evaluate any code live, and you will not only does the system change in some abstract kind of way that's probably nothing where you are, okay, I always wanted to change my editor while I'm at it, but I think what a lot of people would find nice, and we see this with the rising adoption of notebooks and stuff, is that it would be cool to just grab a line of code and execute that without the need to wait for some rollup to finish, then Alt-Tab, and in the end we would need to look inside of a browser console anyways, because we don't have any other log mechanisms inside the browser. And also, yeah, take a look at this browser and just remember this. So what we have here is, or how this kind of browser works, is that you have here some kind of packages or classes, and then you have methods, getters, and you can kind of make it always drill down one step further down in the hierarchy, and that's quite powerful, because you don't have the space problem that you would have if you put that inside of a normal tree, because in the tree you always move the stuff further down the further you expand the single entities. So it's quite cool to just have this inside of a row stuff, and if we go further down, then we can just push the other things to the side and have a scrolling kind of thingy. Yeah. And Smalltalk, although the original version of Smalltalk I just showed is quite old, Smalltalk is still alive and well. There are different implementations of that floating around. I think Faro and Squeak are the most prominent ones, but I'm no expert in that, so I don't want to step on anyone's toes. But yeah, that's a screenshot of Squeak, and yeah, if you can see here, this browser does still live, and you have now, of course, more expressive ways of actually putting graphics there. You have tools like a workspace where you can put code and evaluate that immediately. And what is important, what is important is this. I'm not sure how well that translates over the slides now, but you will see it a lot more in a second. But you can see here we have this turquoise star that is selected, and there are these colored bubbles around it. That's called a halo. I think that was invented when Squeak resided at Disney, but it's not quite sure. And what it allows you to do is perform a lot of interactions with this graphical object via the halo. So if I wanted to take the star and, I don't know, flip it on its head or change the color, then these operations are accessible to me via this graphical interface, and I don't need this abstraction through some kind of code that then I need to figure out, okay, how do I access this specific star? And it also allows people that cannot code, or that maybe cannot code so well, to interact with these interactive elements. There's also eToys. I don't know if you heard of that. eToys is also based in this lineage of Squeak tools. I think today you can find it inside of Squeak. eToys it's also related to Scratch. was the idea on developing tools for programming learners to easier interact with stuff, and that's where these kind of direct manipulation operations, as we call them, become very important. And one can push what I will show you in a second much, much further. There's a great talk that is today, I think, around 10 years old, of Brad Victor. It's called Inventing on Principle. The link is in the slides if you've not seen that. That's super impressive stuff that he shows there. And he also stresses this point that creators need an immediate connection to what they create. And that warrants specific tooling for that. And we don't really have that in computing today. And he's pushing that even further in the sense that he says, okay, we want to solve, like, why do we actually program? We program because we want to solve some specific problem. Ideally, that's a problem that actual humans have. And actual humans do not exist in this kind of tiny rectangle world that we have on displays, but they exist in a collaborative 3D world. They interact with each other. And what he's working on is dynamic land. There are more current demos that you can find online, but what's happening here is that he says, okay, if we have all this live programming stuff and direct manipulation on screens, that's cool, but what we actually need is we need programmable objects, so you can take program code and run that basically on, like, there is a computer somewhere behind this room, but what's happening is that you tell this computer what programs to actually run by these colored dots on paper that you can put into a room, and there are a lot of cameras and projectors, and then the actual code gets run depending on what papers lie there. You can also put keyboards in there to lively manipulate the programs actually running, and you can also build like UI elements, but these are actual physical elements that you can touch then and like zoom inside of a map just via the encoding on these colored dots. But that's way more ambitious than what we will look at right now. But I wanted to show it to you because it's really cool. So this is all like, okay, even if you believe me that having a way of programming where we can directly interact with stuff and we have no real run and development time because we all time is runtime, we can immediately execute any code, then the question becomes, okay, but why do we do program in the way we do if all these ideas have been around since like 50 years? And that's a very valid question. We don't really have the answer. But we have selected a suite of tools that were more or less commercially successful to illustrate what problems might come with these suite of tools. The first one is HyperCard. HyperCard was shipped with early Apple computers, and it allowed to very directly program stuff. Basically, what you did in HyperCard was building with a graphical interface. You built hyperlinked index cards, and that also explains kind of the programming model behind that. You can see here they are sorted in the stack. So what you basically have is a bunch of go-tos, but in a very easy to understand way, because you can just say, okay, if my user presses here, then I switch to that card, and you can very easily flip through that stack to see what happens if you would implement that in this way. The other one is Scratch. Scratch, of course, very direct feedback thing in the sense that first of all you have like the actual playing field and the programming here on one side, and what's also important is that you actually go ahead and arrange these the cat and other stuff. There's also a version of Sendung mit der Maus where you program the mouse and the elephant. You directly move them in a graphical way here, which of course makes it kind of fun for children. And yeah, what I want to draw your attention to, similar to the Smalltalk browser we've seen a few slides before, that we have some kind of inspector tooling here, and that will come up a bunch later. For example, here we can see, okay, this cat has, of course, this image, and we can also see its X and Y position, for example, so we can see properties of this object. Another one, quite infamous, I would say, is Adobe Flash. And although Flash is dead for technical reasons, I don't think, like, it's clear that it enabled a lot of content that was quite unthinkable before, and a bunch of content also just died when Flash went away, because it gave creators a lot of power, a lot of ways to express themselves, because you had this very, again, this very graphically driven programming model available to you. And we see again, like we have here, this is basically what the cat was before. So we have an area where we arrange our contents. We have a tools drawer, and we have an inspector panel. And the last one is Delphi. Delphi was, or maybe people are still using that I'm not super sure about. But Delphi was quite infamous, or Pascal, Free Pascal, that whole array of languages, and that's still around. So you can today download Lazarus and have a Free Pascal compiler running in quite easily. And what they allowed you to do was basically build native applications with. Again, you had this drawer here where, for example, you could directly just take a button and put that into your form that you developed, and then it was very easy to add, for example, a click handler onto that specific button, and of course change all the properties of this button again. And this kind of application is still quite alive and going strong. I think Xcode does something similar. Android Studio, I think, also. So there is a lot of tooling that uses that. There's also Qt Creator and stuff. But the main problem, I think, for all of these tools is that the browser came and just killed it. So yeah, HyperCard was also, before the browser came, was already deprecated. Flash, and I think it's good that Flash is gone, but there are things that we can learn from what Flash enabled us to do, I think. Scratch is on, and all derivatives and similar concepts are quite heavily used, but and there are even like Scratch ports that allow us to do more serious programming than working with cats. But as it turns out, this block-based approach does not really scale. And my personal theory here is that typing is actually just not the issue, except for children. For them, typing is really hard. So for them, it's nice if they can just drag the commands. But all the stuff that is actually hard about programming, thinking about an algorithm, deconstructing it in single steps, and then thinking through it, that still remains, even if we have like these colored blocks. So yeah, that's not actually solving the problem here, I think. And as I said, these tools are quite alive, but they are for native applications most of the time, and native applications have kind of a hard stand with more and more stuff going through the web. And yeah. Yeah.
product at the end, which is pure JavaScript,
Yeah.
runs in the browser perfectly fine. And
That's super cool.
Where they invented also new things on top of the good old stuff.
Yeah.
I'm also 56 years old. I know since a lot of years Pascal and Lazarus.
Yeah.
Just as a reminder, in that area they get better and better, but they are still definitely not the number one on the young people's level at the moment.
That's super cool. I will just repeat that. So it's in the audio. I was just informed that Lazarus is also working on integrating a JS compiler so that you can actually build browser-based applications with it, which is awesome. Yeah, thanks.
It's available since 4 or 5 years already.
Okay.
In reality.
So, as I said, like the browser comes up, and the browser is kind of cool because now we have like a shared runtime that everybody just has on their computer. And Dan also worked at Xerox PARC. He's actually the guy who invented the right-click menu and other stuff. He also implemented the original Smalltalk 80. He saw that the browser comes up, and he also knew of all these ideas that I just tried to show you a glimpse of. And he said, okay, it's not super clear why we were not successful pushing this vision until now. So let's just try again, this time just using the browser because it's there anyways. And that's actually what lively.next then derived from. So I will show you a quick demo in a second. Lively.next is, there's kind of, this project has a lot of history, has been at different universities, different corporations as a research project. Right now it's not a research project anymore, and we will see in a second why that might be important. But yeah, it's important for me just to say also thank you to the people who developed the original Lively, which are, for example, Dan, and then on a personal note, I want to thank the guys at HPI. If you're interested in all of what I'm talking about today, definitely check out the software architecture group at HPI, and a special thanks to Robert Kran, who ported a lot of the original Lively kernel code to lively.next. And now we will go into Lively itself and see what that means, what I talk about all the time. So yeah, we are already here. And this is what you see if you open a Lively world. And you will see this kind of looks like the tool drawings thing we just had in Lazarus. And I can just go ahead and, for example, press this, and then I can create visual objects. I can manipulate them with this halo I mentioned. So for example, I can move them around. I can rotate them as you just saw. And I can also change the structure of these. So this is a GUI framework that works on a tree hierarchy. So what we have done now is I have a morph. This is the outer one, and then I put another one inside of that. So it's basically similar to how you would structure HTML tags inside of each other. We also have here this this inspector where I can change graphical properties of the different things. And then, of course, we can program in this. So this is a fully fledged JavaScript IDE that is also for a large part written in itself. You need some kind of bundle running, so there's some bootstrapping involved, but you can change a lot of this behavior of the entire thing while it's running. And what that means is we can evaluate anything here. For example, okay, now it's 12. I can store that inside of a variable. So, okay, whoa, sorry. Okay. Okay, and then I can also evaluate these variables. So yeah, pretty basic stuff. But the thing that makes this really cool is if we change into something I prepared, these objects can also have behavior. So if we take a look at this thing, now I've opened a tool that is called an object editor, and the object editor basically allows us to change the behavior of a single thing. And this comes with a lot of like nice features for this kind of development flow. As for example, if I go into this code here, and then I execute this .fill, we will have bound this thing already. This will always just reference this car that I have now skillfully hidden. So you don't need to worry about that, and it's really easy to get this workflow where you're changing the behavior of a single thing. And with that, you can already do quite a lot of stuff. So we have this thing here called connections. It's pretty similar, I think, to bindings or whatever they're called in other JS frameworks. So basically what you define with a connection is if this method gets called on this and that object, then call this other method on another object, and you can get some kind of reactive flow going. And if we, for example, go ahead and we have a steering wheel here and a brake and a gas pedal, then we can just connect all these three together and say, okay, here, change how fast you're going, and I can steer with this thing. And it would be really easy for us to now go ahead and, for example, change the code while the car is running so that it drives backwards and stuff. Unfortunately, I have planned badly, so I need you to trust me on this, and we will see more stuff in the next demo. Yeah, so this already allows us to do quite a lot. We can also maybe just to show you one further example of how this tree structure of the GUI framework works. Here I have an object that comes with yeah, in theory this comes with active behavior, as you can see, because the star is turning, and they somehow disappear. I am a bit worried. Maybe we will find them again in the presentation. Yeah, what I wanted to show you is that you can actually stack them, so you have a wand on a wand, and then they do this weird thing where they turn around each other. I don't know, yeah. Live demos are very dangerous. Yeah, here they are. Okay. So what's happening here is that I have the demo inside of Lively just because we are running in the browser. So a morph, we will see in a second, a morph gets translated to HTML. You don't need to worry about that. But since you might want to use other stuff that is already working with standard DOM stuff, you also have the opportunity to insert iframes and then just let them manage themselves. And I just dropped all of these inside of the iframe. Yeah. Okay, yeah, here they are. So Okay, so I hope what you got from that is, okay, we have some kind of GUI framework here. It's called Morphic. It's also had a lot of history, blah, blah. Links are all in the slides. We can evaluate any code live. We can change any code live. We can inspect the state of objects live. And that altogether means all time is runtime. There's no period of waiting between actually writing the code and executing the code. Okay, so let's just do a really quick run through the tech stuff. This might get fast. If you're interested in that, just come to me afterwards, but the second demo is more important. What's happening is I have a Lively server running on my system. The server is basically just a small node application that provides a WebDAV server, which is basically at the moment only needed because we need somehow access to the file system and we are inside the browser, so we just do that via WebDAV. And there were experiments in the past with like server-side scripting and direct manipulation-driven development of Node.js applications where you could actually pull together API endpoints in a way similar to what I just showed you with the car, but that's currently, let's just say, pre-alpha. So basically, we have that to access the file system, and then everything else runs inside the browser. The browser comes with the DOM, and the main magic happens inside of 3 packages. Like the Lively codebase is split into some packages that hopefully have like somehow helpful names. Lively lang is basically our implementation of something that like Lodash or stuff. So there's just a bunch of convenience functions that are used throughout the system. And the really heavy lifting is something that's called Lively source transform. And Lively source transform is the stuff that actually takes like the JavaScript code that I just showed you where I assign like a number to a variable. That's most of the time not what actually gets executed because we have the source transform step that that will do some stuff like scope capturing, etc. So that we have this live evaluation capability. And we have also to achieve that something that is called Lively AST, which is based on Acorn, just to make it easier to do these kinds of transformations. Because we have 2023 and we want to write our JavaScript in nice modules and later bundle them up with rollup and stuff. And we also want to use classes, and then you get in kind of a tricky situation because now you need to ensure that if I change my model here, then all people that import this module also get updated because again, we can change like specific methods inside of classes, for example, or just the contents of modules at runtime, and that's why you need some mechanism to inform other people that code changed here, and that's based on system.js. Then I've shown you Lively Morphic. Like this is the really important part. This is the technical heavy lifting, and then Lively Morphic is basically just the GUI on top. So one could think about using all this in vastly other contexts with entirely different GUI frameworks and even other languages. So there is an implementation that uses a lot of these ideas for Python, where you could, basically execute Python inside of this lively.next thing, because we also have an option to call shells via the node server that is running, and then you can just execute Python on the host system. And there's also a closure script implementation in another project that's called Clocksp, but it's basically the same idea. So this one is this part is the really important part, and the other stuff is more of let's say the cherry on top, especially this graphical implementation. And then we have also a lot of this tooling that you saw, the scene graph and stuff that we call Lively IDE, a wrapper around Git so that other people that are not professional programmers can easily save stuff in there. And what's maybe important now is you might think, okay, that's all quite funny what you have there, but can I actually do something with that? Because one of the lessons we learned from Smalltalk is that people might not want to install something called Squeak on their system, where it's a bit dubious what they actually get out of that. Nobody wants to install anything anymore, but they want to first see that it's doing what they want. And we have 2 ways of achieving that. And I will focus now on the freezer. The freezer is basically a roll-up plugin that allows us to take stuff that we've written in Lively and bundle that up as a static JavaScript HTML application. So it's basically an HTML file that includes a bootstrap Lively script. So you have a very reduced set of Lively calls, and you, for example, lose the option to actually change the code live. But that's why it's called the freezer, because yeah, it's not live at the end anymore. But it works super fine. For example, here you can see this is just a GitHub Pages installation where I have put a demo application, and you see this that actually does stuff, and that was built in Lively. All right. So the problem then was a bit that as a research project, this was always somehow, yeah, okay, we have a hammer, but we don't have any nails. That's quite all right as long as you're a research project and can just research. And somehow, yeah, sometimes you publish something and stuff, but that ended at some point, and then Robin was at the point where he was, okay, I really like Lively, I want to work with Lively, but I somehow need to pay my bills, and that's why he then founded TypeShift together with some friends, and what they did was they made very custom interactive content. For example, you see here like something where they explained how self-driving cars could lead to fewer crashes. And that's where other people, like non-programmers, came into the Lively world for the first time, actually. So now you have designers and you have like people who write storyboards, etc. And then he was thinking, okay, these designers, they really like working in stuff like Figma. So they have these elaborative GUI-driven design tools where they make like pixel-perfect prototypes. They get super elaborate, and then in the end, I need to do all that again because we need to port that to like HTML, JavaScript, whatever. And even worse, this is not a one-time effort, but what will usually happen is some changes need to happen, and then you're in an infinite loop where everybody kind of got frustrated because he always had the feeling of, okay, but I'm doing something that was already done. Why does this need to happen? And then we had the opportunity to work more on Lively itself again, and we thought, okay, let's try to eliminate the step. Let's try to build an actual red IDE inside of the browser that also is open to non-coder folks to work with, while preserving this option that Lively gives us to really rapidly prototype some stuff. And we had some constraints for that. So the first was, okay, we want to share the actual artifact that we're working on. We want to eliminate this step of recreating something that was already done. And the second one, that's more of a pragmatic choice. We're not like, there's not a really elaborate reason why we wanted to have that, but everybody uses Git to collaborate, and then it's just a pragmatic choice to say, okay, we also want to use that. That means we somehow need text files in the end that we can check in version control and share with other people. And what we then came up with was, okay, it would be good to have declarative component definitions. Why declarative component definitions? Because as it turns out, like you need some kind of code if you want to have this collaboration between coders and designers inside of this inside the same tool. And as it turns out, if you want to have a mapping of this graphical stuff and the code stuff, we will see that in a second, then declarative definitions are just a lot easier because there's more or less a one-on-one mapping. So like this graphic stuff does correspond to one declarative definition, and with imperative definitions you would have like an endless option just of, I don't know, adding three texts inside of one button and then ordering them. You could change the order of all of these operations, and that gets really tricky really fast. Because what we came up with in the end was a workflow where we will do it the other way. 1 second. Okay. So this is another tools, the browser I spent so much time on a second ago, and in here we now have modules for UI components. For example, we have this temperature converter that looks like this, and whoop. As you've seen, I can open up the graphical representation just with some handy buttons that are directly at the component definition. We will take a look at the component definition in a second. And what happens now if I change, for example, this? Let's see. Yeah, I know. Do you see that? Yeah, the code changes live as I change the graphical representation. And that even works if I don't have both of them open at the same time, but it's a lot less impressive because you just see the code in the end. But what that allows us is to have designers work in something that is, let's be honest for a second, basically stolen from Figma. Like our palette at the side here is very heavily inspired by them. You allow designers to work with something that they know, that they like. They can just take these things and arrange them in a graphical way, and then we can just, with the push of a button, have this code file that allows us to change that in a way that we like as programmers, and also that allows us to move these graphical definitions inside of Git, because they're just a JavaScript module in the end. And designers and programmers can work collaboratively through that. And what, yeah, maybe we will spend some time just shortly on how this works. What you have is basically you have a component function that you use to define new components, and inside of components you can also reuse other components. Otherwise that would be not so useful, and that you can do with the part call. So for example, we have here this component that is called temperature converter, and in there we have a part that is just called default number widget, which is unsurprisingly this number widget that you see here. And these, I don't know if some of you have worked with Figma or these tools. What's happening in Figma is that you also have like an inheritance style structure of different components. So you can take a component and derive that, and if I change the parent component, then the children get changed as well, but that does not escalate up the other way. And we can do that here as well. So for example, we have the space form, which is just the white thing here that this inherits from. And what that allows us to do, I will press this button now, and now it's actually live. It has attached behavior, as you can see here. And this behavior is defined in a class that is called a temperature converter model. So what we do here is have behavior and the graphical representation detached from each other, separated into different modules, which is the component definition on the one hand, and then we have a view model that you can attach to such a component that implements the behavior, and inside of these view models you have these bindings that basically wire up the graphical elements and the implementation inside of the model. So for example here, if I change the number of the Celsius input, then set Celsius is called. So that's, I think, also very similar to how other JavaScript libraries handle this. And why do we want that? Because we want designers to just live a happy life inside of Lively and design their application away and change everything and press stuff and not fear that some obscure behavior, for example, a close button gets activated and everything is gone. And that's why we wanted to have the separation of, you can instantiate the graphical representation with or without behavior, and that we found then out that doing that via these view models, which we can rather easily attach and detach, is a good way. And what this also allows us, this is called the temperature converter model. What this also allows us is to reuse behavior. So you have seen this small demo with the number widgets, and now we have this exact same behavior, like the exact same model behind this, where we just basically changed the front end of the number widget, which is now this temperature component that has like the same interface as the number widget, and it's just a small change in the UI component, where we basically say, okay, add a thermometer instead of the number widget, and that's the only difference between these two components. Yeah, so that's what I wanted to show you. The important parts I'd like you to have gotten from that second demo is, okay, we have components and parts. These are derived from each other. We can instantiate them. We can attach behavior via view models, and like the kicker of this whole operation is this live reconciliation stuff, where you can actually directly manipulate graphical objects, and a changed component definition in JavaScript falls out at the end. Yeah, I have a few seconds to talk about what we want to do with this next. So this is, yeah, you can use that. I would not recommend building your business on that, but it is actually, you can just go on GitHub, pull that all down, and have a play with it. And what we want to do is, first of all, the bundles that fall out in the end. For example, the demo on GitHub Pages I showed you. These are quite large at the moment, and also the initial loading time of the system, where you bootstrap everything up and load all the modules that you can then later dynamically change at runtime, that's quite slow, and we want to get that faster. We also want to think about, okay, if we can develop applications in this kind of graphically driven way, can we also do that with, for example, tests, because we think that would be really cool to like define the outcome of a test by actually stepping through the behavior inside of the system. And our stretch goal would be thinking about how we can bring even more stakeholders into the system. So for now we have like designers and programmers that both can work collaboratively together. And what we would like to think about would be, okay, but what about other people like marketeers and stuff? What would it need for them to also work on the same artifact? What would their needs be, and what kind of features would we have to implement in order for them to be happy? Yeah. So that's basically what I wanted to tell you. I know it was quite fast. That was my mismanaged time. I'm super sorry for that. As I said, please check this project out if that was somehow interesting to you. It's on GitHub, MIT license. Just pull it. The instructions are there. Join our matrix room. If you do that, we are absolutely prepared to provide quite extensive support because basically at the moment, I think we are the only, there are a handful of people actively using this. So we are very happy for anybody who wants to play with that. And I would say for questions, I think we have a few minutes. So we can do questions now, and the other, if there are remaining questions after that, you just still come to me, and it's not on camera anymore. And I'm super thankful for your attention. Yeah, are there any questions or comments?
Thank you for your talk. So thank you very much. I was wondering if you have considered to bring the plain view you already have into a 3D application, like using a 3JS or any other framework.
There have been experiments with more 3D stuff, but I have not worked on them. So I cannot really, what's the background of the question? I cannot really speak to the additional challenges or stuff that brings, unfortunately. But in theory, that's definitely possible. Yeah.
Okay. Yeah. Thank you.
Maybe just what's happening here is these morphs. So these graphical objects. They just call a specific render function, and what's inside of the render function is totally up to you. So you can just override that. We right now implement HTML rendering, of course, but you could also go ahead and do your own canvas renderer, or for example, speak to some WebGL kind of thing behind the scenes. Yeah. Yeah, okay. Then I would think we wrap up here. And once again, thanks for coming.